are going to stay the next 2 hours or so to do what we can on the 80s. Frankly, if we've left out some technology things that we don't cover well enough today, we have time during the sessions when we do the business discussions on Adobe or on Aldus and so forth, that we can pick up some of those pieces tomorrow. So I'm not going to beat myself. The background things that I still think are fundamental that we haven't covered quite that I'd like to, we want to talk a bit more about the laser printers and how that evolved, because that seemed to be so fundamental. We want to talk a little bit more about fonts and how that developed. And we want to cover PostScript, we want to cover PageMaker, and because of a time conflict, I'm going to start completely out of sequence and talk with Steve. We're going to use Steve Kirsch and talk about FrameMaker before the others. I have left out one. I'm going to give Donald only 5 minutes, but we want to talk about text. You talked a little bit about in your introduction about why you came up with it. I'd like to talk a little bit more about the technologies, what you did or what was done to make that thing so productive and so useful for so long.
Okay,
and you're not allowed to eat while you're talking.
As it had nothing to do with commercial plans. I was in a situation where I already had sort of all my life's goals were accomplished. So I didn't need it. I didn't need to do something else. So, but I did want my books to come out looking good, and so I researched as well as I could what that would take. But I thought that was going to be a more or less private system at first, and I found that it seemed to me that this that the publishing world was being held back because everybody was doing proprietary stuff, and I knew very well that I'd studied the history of compilers, something similar. I thought of tech as kind of a document compiler, but compiler was a system for writing, for getting programs into machine language, and we had a model very important in my mind was Fortran. IBM had decided that it wasn't going to control Fortran and exclusively have it be an IBM thing, but every manufacturer would be able to have their own Fortran compiler. So I said, publishing industry is being held back because everybody who comes up with a good idea about how to make good books, I was thinking more about books and newspapers, everybody thinks, okay, but that's going to make their fortune. And I didn't need to make a fortune, so I said, let's just figure out what it would be and hope to get cooperation instead of competition. And so that was very much in my thought, and it turned out then that I got volunteers all around the world to help make this happen, and so this is really one of the main things here. Now, how did it feed into the actual commercial things afterwards? Well, as you know, some of the people on my project turn out to be very useful in FrameMaker, et cetera. Okay, but more than that, it found a real niche in the area of mathematical publishing, which nobody else cared about, and so it become to a point now where I think it's more than 95% of all mathematical documents have been done in tech, maybe for the last 30 years, and the other main goal I had was that it would be frozen and not continue improving, so that somebody could write a document and assume that somebody else could get that exact same document 20, 30 years from now on whatever computers are available then. And so those were the kind of things I started out with, and I had wonderful cooperation from everyone else. And I invited to Stanford. You're going to talk about fonts later, so I'm going to come back and talk then. But I invited to Stanford not only Chuck Bigelow, but many of the other leading font designers of the time for short visits. And so we had I didn't know that fonts were going to be so complicated at first, and as I said, I thought I'd finish the whole project in 1 year. But in 1985, I did think I had finished it, and we had a celebration in Boston at the Computer History Museum in Boston to celebrate the completion of the tech project at that time. And then, however, I found out that there were lots and lots of users who would come out of the rest of the world where they couldn't afford to buy any of these typesetting systems that other people were buying. So for example, in Eastern Europe, all kind of people had started using tech. I mean, people were using tech in Iran, in Turkey, eventually in China, everywhere, because it was public domain and they didn't have to pay for the things. They could make their. I had tech users in Ethiopia that were able to make their books in Amharic, and this was because I had made the system without license and so on. In order to take advantage of that, I had to do another. At the end of the 80s, I spent another year or two making it so that it would work well with the other languages of the world, that you could hyphenate different languages at the same time and things like that. So that's my short summary of.
I have just a couple of questions. Maybe some of you want to add to this. That area, everybody uses text. Who produces the processors that allow them to do it, to produce the books?
I never. Okay, so it was all user generated. I never went out and what do you call it? Advertised it or anything like that. I didn't do anything to promote it. But by having at first people got a thrill out of being able to help port it to other machines. But after that, then we got more users, and they started realizing, they cared about quality typesetting too. I wasn't trying to do something where I wasn't trying to, for mass market, any sense. I mean, the whole idea of having something where you would distinguish between left quotes and right quotes was way out there for most people. M dashes and N dashes, but I wanted something that would, for the person who wanted to go the extra mile to get a book that was as good as anybody could make, rather than something that was good enough.
But my question, so people are producing for each individual computer, each individual process? I mean, somebody's writing programs to make this language work. It's like with Fortran, every computer manufacturer did.
I wrote the program myself, and I wrote it in a portable way that could be easily converted to. Not only easily converted, I was careful that it didn't use things that would run differently on different computers. So, for example, I don't use floating point arithmetic because you couldn't trust IBM floating point to equal a Honeywell floating point or whatever.
What language did you write your program in? What language did you use?
The original language was Stanford Artificial Intelligence language, SAIL, but then I converted it to Pascal because I wanted people to read my program. And at one point, I think for a program of its size, it had more people who understood that program than any other program in the world. But then Pascal was an academic language, and it was quickly ported to other languages. But I introduced, to me, the most important thing for me was that I also introduced something called literate programming, which is a way of writing programs that is intended to be read and understood by human beings. And
This is a practice that was only used in the Dark Ages. So it's no longer practice today.
Yeah, it only has a few 100,000 users now and a few Academy Awards to show for it. But anyway, Dave can say more about that. But anyway,
Just one thing answering Bert's question. Today, the Pascal web environment goes to C and then goes
Yeah.
everywhere else.
right.
So C is the current language in which it's been implemented?
It's in C Web.
Thank you.
Yeah.
Look, it's a wonderful story, and for a lot of the people who do this kind of work, it's a small subset. It doesn't have the commercial opportunity or money, but it's so valuable to the whole universe. Thank you.
I make one comment.
Of course,
There was the Seabolds organized a seminar or a meeting at Stanford in 1980, I think, which is where I first met Don Knuth. And at that, there were several commercial manufacturers of composition software that drove Linotron 202s and VIPs and other things. And when after the seminar, Don explained what it was, and we saw his students do things. Somebody was asking the commercial developers what they thought of it, and they all said, well, look, it isn't fast enough, the coding isn't clear enough, and we do it much faster and we do it much better. None of them are now in business. And tech
Don is
has,
not in business. His stuff succeeded.
his
That's
stuff
wonderful.
has succeeded way beyond and in far greater numbers of distribution and usage than any of the commercial programs that could handle math at the time. Unless, Jonathan, you have...
I would say that there's another fundamental difference, and that is that this was written for the authors to use. Just as the newspaper systems, the people who are writing, the act of writing is done on the terminal, okay? Everybody that I know a number of people who use tech, and it's a standard format for papers and for books, and you can deliver it to the publisher in tech format, everyone does. They write in tech, or LaTeX, or some variation there. So this rapidly became not just a publishing system, but a sort of authoring to publishing ecosystem, if you will. The tech and the stuff is built around tech.
We're going to move ahead. And any one of these we could spend an hour on, so I'm being very selfish. I thought it's a little out of sequence, I think, from a time frame, but let's start with FrameMaker and with your company, with Frame Technologies. Steve Kirsch.
Sure. So before I do that, I wrote my master's thesis at MIT in tech. So, thank you, Don. And I'm sure a lot of people are still using it today to write their theses. So, do you like the background, or
Looking for a technology, where did you come up with the ideas? What technologies did you develop? We'll talk business tomorrow, but today talk technology.
Sure. The genesis is that I had a relationship with Sun Microsystems because I started a company called Mouse Systems, which made optical mice. And Sun was one of our first customers, met a guy named John Gage there, who was their chief scientist. And long story short is that one day he called me up and he said he had ran into this guy, Charles Corfield. And Corfield was this genius out of New York. He was just a really, really smart guy. He talked his way into a loaner Sun workstation, because Sun was always giving out workstations for promising developers. And so Charles got his hands on one, and he started developing this prototype desktop publishing system to ostensibly compete with Interleaf, who was much more well-funded and well-staffed at the time, and he was just a kind of a very smart guy with an idea of building a good publishing system. So I started talking with him and was pretty intrigued, showed it around to people, they were intrigued. Hooked him up with a guy named David Murray, who had developed FileMaker on the Mac. And so David was kind of the UI specialist. And
Period. When we talking? Give me a date.
July 1986. And we also, there's a guy named Ken Keller who was one of the founders. So he was also very technical. David Fuchs used to work on tech. And so those were and then myself were the sort of the technical, and I was more on the business side, so I stayed away from the code. And so Charles, so David Murray lived in Morgan Hill, so Charles rented a house in Morgan Hill, and David and Charles would essentially code, and these guys were like, Charles was a maniac. He could like code for 36 hours at a time, and then he would take maybe 8 hours sleep and go another 36 hours. Just amazing, from physical stamina as well as brilliance. And so he got the whole thing, with David's collaboration, we got the whole thing kind of up and running, and it was great. I mean, we had this notion of these frames where you could have a block of text, and you would put text in it, and you would link this block with that block. We called them frames, and so you could flow things very easily. And so it was very, very flexible in that respect. And there was just one slight difficulty that, it's kind of like the, John and the Adobe problem, is that Charles had never really thought about printing. So he had this whole thing designed, and printing was an afterthought. And so it was like, okay, can we actually get this thing to, it looks great on the screen, but can you actually get it to print out? So then Charles got the PostScript book and started reading PostScript. And I think it was like, 2 weeks later that they had it printing out. And so it was developed on Sun workstations.
Who was your market? Just
It was technical writers. And
pardon?
yeah, someone's a big customer. And Interleaf was quite popular, but Interleaf was a bit harder to use and a lot less flexible in terms of the design layouts that you could have. It was very structured, whereas FrameMaker was the very unstructured version of it. So if Interleaf was very structured and Aldous is sort of page-oriented, we were in this niche of being able to do very long documents, but also have the flexibility of layout. So that was our niche. And so people, tech pubs was our focus. We distributed on these little mag tape things that you would stick into a Sun workstation. I forget some tape, I forget the 3M cartridges, and so we sold, it was called Prototype FrameMaker 0.6, and we sold it for $2,500. So this is prototype software we were selling for $2,500 a pop. And that helped to bootstrap the company. We sold software licenses to Toshiba, and also to Digital Equipment later to help fund us. And then we got venture capital somewhat later.
We'll talk about the royalty things and so forth tomorrow.
Okay.
Where did the ideas?
Hammerton Quist, by the way, was also an investor.
Where did the money come? Where did the original ideas? Who had the idea of doing it this way?
So Charles had the idea. So it was just one guy in an apartment in New York. And then, huh?
Pardon me?
It was just to do desktop publishing.
Was it kind of an Interleaf clone?
There was a different way of looking at it than other people did, apparently.
Yeah, it was just hey, here's how I would do. Here's how I would solve the problem to create a flexible paradigm that could be used to create any sort of documents, whether it's a one-page document or it's a 200-page manual.
This idea of the frame was a different thing, that each thing was movable or controllable that way?
The idea was that you could have, instead of it being like Interleaf at the time, and systems at the time for doing longer documents were very structured. They would say, you know, you're going to have the 2-column layout, and it's fixed, and you're flowing the text in 2 columns, and you can't really do anything to break that. Whereas here we treated a page as a canvas, where you could write on it in very much the same way as Aldous PageMaker, but we combined it with sort of structured and long document thinking. And one of the innovations that we had, that David Murray had, was this thing called the MIF. It was called MIF, Maker Interchange Format, where we could dump out the document. So it was a portable, you know, it was like an XML version of the document. And so instead of putting it out in, you know, it's sort of like the content version of PostScript. You know, for PostScript is for printers in a printed representation. So we had a way to dump it out in a version invariant form, such that it would preserve the semantics of what you're putting into the document itself, not how it was laid out.
What,
you know,
what language did you use
it was written in C.
from the beginning?
Right.
Then C+ later on, or?
No, it was all C. Charles just learned how to program in C, so that's how he, you know, I mean, it's how things are done. And it was fast.
I was going to say, why was it so much faster?
Well, number 1 is written in C. Number 2 is written by one guy. Right. So one guy, you know, because he knew all the pieces. He knew where everything was connected. Right. So, and he was just brilliant. Right. And he could code for just, you know, enormous stretches at a time. And so he's extremely productive and extremely smart.
Was it difficult to debug? Did you have a long testing period? What did you?
Not particularly. You know, people would beat on it, and we'd log bugs, but you know, we didn't have like a formal bug tracking system. It was a small group of people, and we got it out to people, and people would, you know, send in their bugs, and we would fix it. I think the biggest thing that we had is that we. This kind of like anecdotal funny stories. Everybody has their set of funny stories, but we had, Charles was really concerned that he didn't want people using the prototype software after a certain date. So there was a time bomb in prototype FrameMaker 0.6, where after a certain date, the software would cease to function because it was too much of an embarrassment to have 0.6 out there. It was just like, you know, an ego thing that I, you know, didn't want to do that. And so we had now, you know, like 1,000 people using this 0.6, and the deadline was approaching. And so we're at the final release, you know, so we could get it out before the software exploded on everyone. And we didn't exactly tell people that this was the case. So we had to go and ship the software before it blew up on people. And so, you know, we had the whole thing working, everything was going fine, and then, you know, you said, well, do you have any bugs? And like 2 days before the deadline, we're all done, and the software was crashing. And we couldn't figure out why the heck the software was crashing. We'd look at the dump files, and it would be complete nonsense. So, you'll never guess what caused the problem.
Tell us.
No. It was a bug in the Sun hardware. Okay, I mean, it was like the last thing you would ever think, that we discovered a bug in the Sun hardware, where if you took a page fault, that it would clear a certain register. And we just happened to write our code in such a way that it triggered that. So we were like, you know, sweating bullets. We found this thing. We said, whoa, this is a bug in the hardware. And then we verified it with Sun that it was a bug in the hardware. We wrote a workaround so that it wouldn't cross the page boundaries. And we shipped it just in the nick of time.
Now, did you charge them more
Everybody
than-
has everybody has a story like this. Huh? Yeah, well, just before, we got it to people in time. So this was like, you're sweating bullets. This is like,
Did you charge them more money at that point?
no, we still charged it. It was like $2,500 a seat, and we pioneered this notion of a floating license where you'd have one license active and you can use it on any machine. And so it was a number of sort of simultaneous licenses. So it's pretty innovative concept at the time.
One last question for me. Did you port it to other machines besides Sun?
Yes. So it was Steve Jobs had us port to the next box. We ported it to PCs. We ported it to Mac. We ported it to X Windows, and we also, I think, we ported it to Sun Windows as well, to the news,
questions,
the
or-
news Windows system.
You don't have enough big enough market? Was that the problem?
Well, it's just a question of resources. But I think the Mac was, I think was probably the second one that we ported it to.
So one of the distinctions I think is vital here between you and Interleaf. Interleaf was the old model where publishing systems were built on proprietary hardware. Interleaf was built on a Sun workstation, but they sold it as a hardware-software package.
Right.
Whereas you were selling software only, which was
Right.
the new generation, the sort of desktop model.
Yeah. Yeah. So we were trying to be the new, hip, cool, Interleaf had these super expensive sales offices and, hired really high-priced guys, and we were like, just the total opposites. We were the Silicon Valley version.
Right.
That's a great
And,
story.
we didn't bundle it in. We tried to keep the prices low. We tried to keep it affordable. A lot of attention on the user interface. Kevin Lynch was the person who was in charge of the Apple product for us, and Kevin went on now he's the CTO for Apple and was in charge of the Apple Watch. So, yeah.
I'm going to cut this off at this point. We're going to go to PostScript. So we've got their two people there. That's however they team.
So you have to tell us how the story.
So I'm going to start, and Chuck's going to correct me.
This is the technology story.
That's the drill here. When we started, we were going to be in a business model very much like Interleaf, and we were going to work on Sun workstations and build a printing architecture to go along with it. And that is...
I didn't get that.
Totally appropriate. But after talking to Digital Equipment Corporation and talking to people, DEC had been working for years and years and years on a printing protocol, document protocol thing that was volumes deep. And we talked a lot with Sam Fuller, and we talked a lot to Gordon Bell, and they said, gee, we're really interested in the printing protocol.
Give me a time frame.
In 1982, just after we started. So we started December of 1982. And we started implementing first. We were going to do PostScript. Okay, so we had a fairly good idea of what we wanted to do. We wanted to build essentially, there was a language that was called JAM, which stood for John and Martin, because Martin Newell and I put it together at Park. And it had a full imaging model, and we said this would be appropriate for driving a printer. So we started working on that because Steve Jobs had hired away a whole bunch of people from Park. He learned that we had left Park, especially from Bob Belleville. And he called one day and said, gee, can I come visit? Because I hear you guys do interesting stuff. And so he came over and we were showing him what we were doing. And you have to remember the position that Apple was in. They had mimicked the Alto, okay, in the sense that it had the same kind of graphic interface, a much less expensive machine. You had a floppy disk, and they were about to announce the Macintosh. They tried with the Lisa. The Lisa didn't do so well, a little bigger. So he wanted to build a smaller machine that anybody could buy. So he built that, had the little bitmap drawing programs, had built bitmap fonts, had the original Mac operating system working. But the only printer that they had was a dot matrix printer that would print out the image of the screen, which was total crap. I mean, and he recognized that there was no bloody way in hell that he could sell that into a business. So when he saw what we were doing, he became incredibly enthusiastic. And he offered to buy the company early on. And we said no.
We said no.
We said no. So we worked with Steve and we talked with the engineers, and we had engineers, and we decided to go into a co-development arrangement with Apple to build the laser writer. So we had Dan Putman, who was a very accomplished engineer and board designer, and he worked with Belleville and Crowd to build a board for the laser writer. It had 1.5 megabytes of memory, and it had 0.5 megabyte of masked ROM, where the code was going to go into. And we signed a contract in November, and this was in '83, and they were going to announce the laser writer in '85, and they were going to announce the Macintosh in '84. So we changed our business model, and we decided that it was going to be a big enough business opportunity because of the interest in PostScript to build printing software that was going to be in. And this was kept totally secret. And so we worked like crazy. And we didn't have fonts, we didn't have anything. So we hired Liz. We went to ITC first and got the ITC contract. We jointly, and both Chuck and I convinced Steve that he had to have real fonts. He had to have Times Roman. He had to have Helvetica. He couldn't have Chicago. He couldn't have Monaco. These bitmap fonts were just not going to fly in a business environment. And I mean, we really pushed hard. And we worked together, and we got the first Linotype license in the world, because when we approached Linotype, we showed them the device independence. And when he said, the same thing you see on the screen, same thing you see on the laser writer, you can see on a 1,000 spot per inch machine. And we can drive a plate maker. They had a head of engineering who was very progressive, and he talked Kumar, who was head of Linotype, into taking this leap of faith, which was totally against the psychology of the typesetter world. Typesetter world was, you buy our typesetter, you buy our fonts. My fonts don't work anywhere else. Typesetter doesn't take anybody else's fonts. That's the way they all work. And so you were sort of, in the typesetter business, you were sort of married to your install base. You provided the fonts, and what we said, well, okay, but what's going to happen is all of the ITC fonts are going to be able to run on anybody who builds this RIP, and fonts are going to become interchangeable. This was very disruptive to the typesetter industry. Jonathan, interrupt me whenever you want to correct me. So we started in the implementation, and there were some difficult problems. The font problem was probably the most important, because if you do, as Butler said, the most straightforward thing and scan convert a letter and put it on a 300 spot per inch machine from an outline, it looks terrible. Okay, and so we knew we had to solve it. Now, the way people had tried to do this in the past is they would put the letter outline up on the screen, and they would figure out what bits to turn on and turn off inside of the letter to make the letter look good on the printed page.
By hand.
By hand. Okay.
And for every point size.
And for
And
every.
for every resolution of output.
I
and
guess
for
I've been
every
told
print.
that it amazes me that as it gets bigger or smaller, you
Oh,
can't
yeah.
just scale it up and scale it down.
You can't. No, that
That's
will.
because there's not enough dots in one stroke.
Oh, so it was the fact that it was a bitmap.
Yeah, if it had been at 2,000 DPI, it would have been okay.
Yeah, even at 600, it would have been okay. But on a 300 spot per inch printer, if you didn't have these bit-tuned bitmaps, the page looked crappy. Okay, so the simple fundamental idea, it's so simple, we didn't patent it. We kept it as a trade secret because it would be too easy to work around. So the same idea, the basic idea was don't figure out what dots to turn off and turn on. Modify the curves in the letter so they line up with the grid, so the frequency of the verticals in the letter line up with the grid. So what you do with a Bezier-defined curve is all you have to do is transform the control points. You don't have to transform anything other than the curve. You don't have to subdivide the curve down at all. All you have to do is transform the control points, yes.
Okay. There was another idea floating around, that is to move the grid, to distort the grid. There was this company on Page Mill Road that I visited, that Harry, what's his name?
Well, in some
Manus-
sense, they're equivalent.
Yeah, okay.
Okay, but it's a nonlinear grid. In other words, you squish and put, if you modify the curves, okay, then you can get the x height and the x base to be the same because you have what we call blue lines that would change x heights. And then you had the two staffs of, say, an M that you would modify by 1 pixel by the curve so that it would make perfect scan conversions.
So you had to know that the two guys should be the same width.
Yes.
That had to be
Correct.
part of the
Yes,
definition.
so those were called yellow points. Okay, there was a yellow point on every vertical line, and you knew that those had to line up with the grid. So we coded this up and tried it, and the results were bloody amazing. It just worked like a charm. But we noticed one other thing, diagonal lines are too heavy. So what you do is you squeeze the grid on diagonals. You don't squeeze the grid, you squeeze the curve. So the whole trick in rasterizing fonts is to modify the curve, not the grid. Okay, and then all the diagonals show up. Now, if you rotate the letter, none of it matters
Got to stay.
because it's not beating against the frequency of the grid.
You say you patented this?
No, we didn't patent
Or you
it.
kept
It
it
was
as a trade
We
secret?
kept it.
Because we would have had to disclose,
Of course. That was one of the reasons I objected to patents.
and we
And-
figured it better to give the employees stock options, make them owners, then they don't give it away.
So the secret never got out?
No.
I
Well,
couldn't hear you.
until the 1989 Seabowl Conference, where we said we will publish the Type 1 spec. Okay.
This was your foundation.
Well,
When
this
does
was
it get running?
this was the technical thing. This was the technical thing that worked. Now, it almost worked on the screen. Screen resolutions are so low. So when we got challenged by Microsoft and Apple in 1989 at the Seabowl Conference, we went back to Adobe and we said, we're going to out-invent the bastards. We are going to build
The
the
bastards were Adobe. Apple.
we're Apple and Microsoft. Okay, so we went back and Bill Paxton figured out how to get the font scaling technology to work at screen resolution. And he not only did that for for Latin alphabets. He did it for Japanese and Chinese, which was a tour de force in programming.
So what was the trick?
What, on the screen?
Yeah.
On the screen, there you want to look at the rasterization and you want to look for anomalies of bits. Okay, and he would say, gee, if you see this anomaly, kill the bit, because scan conversion at low resolutions had a tendency to be too dense. And so he would
Basically throw away bits.
he would throw away
That
bits,
looked like they were particles.
but he would keep the continuity of the letter.
There's an amusing story about this in the context of Microsoft. I don't know whether this was a good decision or not, but the Microsoft guys who were worried about screen fonts decided that they needed a great deal of flexibility in controlling things in difficult situations. And the way they decided to get this flexibility was to allow you to turn the character descriptions into little programs. And the little programs were written in x86 machine language. And this turned out later to be a terrible security problem.
So,
Stop for a second. So the biggest thing in terms of
Hard to
getting,
believe, but true.
in terms of getting this to be an operating program was the handling of the fonts. This was your biggest stumbling block?
They already knew how to do PostScript.
Yeah,
So
there
you didn't
were,
have to invent that so
no,
much.
no, there was one other. So I bow to Don Knuth, because what you have to do to build a reliable scan converter for an arbitrary polygon is you have to do it in fixed point. You cannot do it in floating point. There is no bloody way that you can take a floating point representation of a polygon and reliably scan convert it. That was another thing that we learned, and it's a lot of very difficult, very tight code that does that fixed point conversion for very long integers.
What did you write all this code was
All
written
this
in
was
what?
written in C.
see.
What
The
was
other
this code?
challenge we had is we had only half a megabyte of space. And it would be in masked ROM. So if there was a bug,
You're
you're
screwed.
screwed. So we built an escape patch, which we very seldom used, but we could actually go in and put something in the printer in some RAM memory that would allow it to fix the bug.
So the amount of testing that this went through. So the other largest masked ROM burn to that period had been done by NASA for the space program. So this was a huge amount of ROM of code to put into a board.
So what machines were you using, and what language were you using to do all this work?
We wrote in C,
You did, okay.
and the machine was the specialty board. It had a 68,000 processor on it. It had 1.5 megabytes of RAM because
You had to bitmap of
the bitmap of
page.
the page was 1 megabyte, and then you needed some working space. And you couldn't really fast enough make the scan conversions of the characters, so we had to build a font cache in which we
And
sort of
since it
remembered.
was locked into the raster by changing the curve, you could replicate it to any other raster position and it would still be good.
Yeah.
You
So,
had total portability, you felt, in that regard.
yes. Well, and you could do it at any resolution, and that's how it worked. Changed
And
It was our
Steve,
Bezier.
Bezier curve, but what you said.
Steve, we're not picking you up. Never mind.
Oh,
Sorry, John, may I ask, was there any connection between PostScript and the work that you were doing at Evans and Sutherland earlier?
yes, because the basic language of JAM that Martin and I did was developed actually at Evans and Sutherland. And so the way the stack architecture and everything was done on a PDP-11 at Evans and Sutherland. So when we started Adobe, we licensed that technology from Evans and Sutherland.
Okay. Was there anything conceptual, and was that simulation work that you were doing?
Yes, we were building database models for flight simulators.
But it was only the programming language that was
Only the
in common?
language,
Oh,
Okay,
yes, that
got
was
it.
the only.
nothing to do with the
Plus,
graphics generation.
some knowledge about graphics and mathematics and stuff like that.
Thank you.
E, you had a question?
So back on the font breakthrough that you had on rasterization, these blue lines and yellow lines, so did you basically shift to the font designer the responsibility to give those hints?
No, anybody could do that.
Anyone could do that once you knew the trick, basically?
Yeah.
Okay.
Well, and you would get it from ITC, you would get a font, or you would get it, and all you would do is draw the lines on the vertical stems and draw where the X height is, and
How many different
We
fonts?
hired our children to scan the output from the type, and then we wrote a
Converted.
program to do conversion on the
to Beziers.
on the Sun workstations.
And I thought you told me that that didn't work.
No, it
No, no,
worked.
no.
It worked.
You said
It worked enough to give them give the designer a place to start.
I see.
Yes.
Then you had to have pros actually
Somebody,
finish it.
well, someone
Yes.
who was in the type, who knew about typography to do it.
On the market today, there may be 20,000 fonts.
How many did you have to have, you felt at that point in time, to be
The starter set for the laser writer was 35.
35 fonts?
35
How many sizes?
Any size you
Any
want.
size you wanted.
That
Doesn't
was
matter.
totally flexible.
Totally
It was no longer
flexible.
that
You can
restricted.
rotate them, you can
You
stretch
said there
them,
were
you
10
can do
sizes
anything you
before.
want with them.
No, that was, the 10 sizes were for the bitmap fonts.
The hints were put in manually.
So today, do you need, are fonts still done, a new font, will that be done manually, or is it, do we have tools now that can do all this stuff automatically?
I'm sure that they have the really simple tools to make this a piece of cake.
But humans is still involved, or it can be
Well,
done
the
totally automatically?
Font designers, new font designers.
within the format that contains it.
Yeah.
Done.
Have Jonathan next.
No, we had to mark.
We have Jonathan, then
Let's just-
Tom, then Mark.
Let's just sort of reinforce how seminal PostScript was. Until this time, every output device had its own language, and its own set of fonts. And they were a limited subset of what was possible. And they had their own counting systems. So that if you wanted to drive, as we were doing in the 1960s, wanted to drive different output devices, we actually invented a virtual machine and treated everything as a subset of that. The common practice was not to do that, but to write more directly for the individual machines. And these were typesetting machines. They could do type. They couldn't do anything else. And this was a huge, huge problem. So when John first contacted me about PostScript, my reaction was either this or something like this has got to be the future. But this is how you get output device independence and resolution independence. And without that, we can't really go where we need to go. So this was absolutely seminal to everything that happened. And the thing that was really great about it was that you guys conceived this not just as type output, but as page output. The ability to describe everything that would go on the page. It took us the rest of the decade to catch up with PostScript in terms of all the stuff we could put on the page. PageMaker couldn't do it. In fact, QuickDraw on the Mac couldn't do what PostScript could do. The problem was only solved when the Mac got PostScript as its native.
Well, and when we announced Illustrator.
Illustrator and
Yes.
Photoshop. And
Right.
made all the tools
Well,
to produce.
we'll talk about it later, but Illustrator, Photoshop, and then moving the stuff that had been in SciText, Crossfield Hell, down to the desktop with this Photoshop, but all those tools came later in the decade. But PostScript had the ability to do that stuff from the beginning.
Right.
So,
We left design room for color,
yes,
which was really critical.
yeah,
We also realized that printing is an international business.
yes, exactly.
And so I began traveling to Japan. I went to the leading printing company there, Shaken, and we wanted to license their library, as we had done with Linotype. And I could never get to the second cup of tea with the lady who was running Shaken. Her husband had passed away and she was running it. Turns out at the beginning of World War II, Shaken and Morisawa were the two people running the largest printing business, and they disagreed about the Japanese approach to the war. Shaken, who supported the war, stayed in Tokyo, and Morisawa went to Osaka. So we went to Osaka, number 2 guy. and who also had a very well-renowned library. We eventually convinced him that we could help him take over Chuck Hen's business if he went with us. So we got the license agreement. We started working with them, building Japanese typesetting equipment. In effect, we converted PostScript so it could handle Japanese. And they are now the most successful printing company in Japan. And it's the only company with whom I've ever had the wife of the owner invited to dinner at a Japanese restaurant, which is a sign of the kind of respect that they have for Adobe.
I get a birthday card for Mr. Morosawa, sort of every year.
Every year.
Second. Tom, you had some questions?
Oh, yeah, so when you were discussing the challenges with PostScript and how cool it was, the focus was really on fonts and rasterizing. But of course, I mean, PostScript is a programming language rather than just a markup language. So did making it a real programming language have any kind of important influence on how it was used or its success?
Yes, it was a disaster.
Did you give him a note to pass that question?
So I have had a strong bias in my life. I have never been a fan of declarative protocols, okay, where you declare things rather than program things. So procedures can always bail you out of corners. And so that's just the way I am. So having it be a programming language not only saved our bacon 100 times, because what happened with Apple is they had their own printer interface. They had their own graphics interface. QuickDraw. And so the trick is you write a PostScript program that takes QuickDraw and renders it, okay? And the Mac didn't have enough memory, but the laser writer did. And so the QuickDraw emulator was done down in the printer. And every customer had their own protocols.
Windows.
And what they wanted to do is take their protocol and translate it so they would write something in PostScript. They would either write it in C or they would write it in PostScript to do it, and so they could send it their protocol and it would print. So the advantages, and where, I have to tell you where Acrobat came from. Because PostScript has the property. Now after we had signed up our 35th or 45th OEM for making PostScript printers, it was and we started working with standards. It started to become a standard for printing. So all of the output in the world had PostScript drivers so that you could drive a PostScript printer. So every document produced on Earth has a way of producing PostScript. Now, the cool thing, I have to tell you this one story. Before we announced the laser writer, one of our greatest sample pages was an IRS form that I hand-coded in PostScript. All the dashed lines, everything, half-tone blocks, the whole page composition was hand-done in PostScript. So when you ran that on the laser writer, it took 2.5 minutes to print because there was a lot of execution involved in printing it. And Steve Jobs said, no, but I want to use this in the introduction of the laser writer. What can you do? Well, in PostScript, you can redefine what an operator does. So a move operator normally moves the cursor wherever it is to a position. A close path operator closes it, a fill path fills it. And so those are the basic operators of the graphics machine. So what you do is you redefine all those basic operators so they don't do any graphics, they just write themselves out. So if you have 2 coordinates and move to, you write out coordinate 1, coordinate 2, move to a file. Well, it turns out that that's a linearized PostScript program that has no loops in it. It has no procedure calls in it. All it has is graphic commands, and we called it binding. Well, if you want to make a PDF file, you run it through a program that all it does is linearize the graphic execution, and you can separate the pages, and you can do all the things we love about PDF. And that's where PDF came from.
No, I'm sorry.
We had Mark.
Mark was thinking was next.
Anyway, PDF is our biggest program, our biggest revenue generator.
So how was PostScript different from other page description languages? I guess Imogen, and did HP have one at that point? And what was the very early laser printer business like?
Well, the other printers all had sort of brain-dead protocols that drove them, like, here are my letters, here's the size of my font, go down here and put out a line, okay? And that's essentially what the HP PCL printers were. They were sort of, here's my line, here's where you put it, here's the letters that are in it. Yes.
They were more like what had people been doing for years for typesetting command languages. Okay, that's the mold that PostScript broke.
Given that you'd worked on Interpress and other similar types of things at Xerox, was there a challenge getting out of Xerox to start this company with the rights to what you needed to go?
There is nothing, Interpress and PostScript sort of have nothing in common other than
the two of you.
Yeah, well, the two. And the fact that I had implemented a language that we had originally done at Evans and Sutherland, when we were confronted by the Xerox lawyers, and we went to meet with them.
Confronted is a little strong.
Well,
They would have
they were
confronted,
concerned.
depending on how it went.
Then they said, well, we understand you use Jam. And I said, yes, we did. And he said, well, you know, Jam is proprietary to Xerox. And I said, first of all, there was a course taught by somebody at Park at Stanford that taught Jam. So it was divulged. And I said the second thing is, it's a variant on a language that we developed at Evans and Sutherland, and we have a license to it. And the lawyer sort of went white, and that was the end of the
Because he knew that
discussion.
Xerox did not have a license.
Sorry, who didn't have a license?
Xerox.
Right.
Sure, I comment. He just was making sure you were telling the truth.
Okay, two things. First of all, I wanted to reinforce one of the things that John said about, well, he talked about floating point, but actually PostScript is not only a beautifully general programming language, but it also is extremely difficult to implement. And so if you didn't have an authorized Adobe implementation, chances are that it had bugs because of strange things that can happen with rounding errors, and the algorithms for manipulating graphics are extremely tricky and subtle, and all kinds of special cases can occur, and they do occur once every few days in the non-genuine application. So that was an important thing for their company, that they were the only ones who knew how to implement PostScript, even though the semantics of PostScript were public knowledge. But
At one point, about 3 or 4 years after the laser writer was introduced, someone counted up 70 clone developers of PostScript who were trying to make a business out of taking away our business, and none of them ever succeeded.
No.
Liz, you had a comment?
Okay, so my own experience is what do you call it? Let's see. Inside the machine, you had the program that starts with an R that renders the PostScript. Anyway, I had a page once that took 2.5 hours to compute.
I've had pages that take that long.
Right, because but then I got to work as an unpaid consultant to Adobe, and you had a machine that was much bigger. Oh, it's a RIP. That's it. The RIP.
Yes.
Yeah. Okay. So, but early on, I have a very strong memory of visiting Xerox Park, where Butler Lamson was, I think maybe John was in the office, but I was going on the corridor and I looked inside the office and there was a terminal that had a great big letter, capital letter B on it. And they were going around the outside of that B with splines. And I said, that's the way I'm going to do my fonts, because I wanted to typeset my book and I needed fonts. And so I said, okay. I approached Xerox and said, can I come to, okay, first I tried the Stanford AI lab and I found out that if I try to use a TV camera to look at a letter, then a tiny adjustment in the light would change the width of the stems by 10, 20%. It was completely impossible to do any quality work. But at Xerox, they had good cameras and something. So I asked Xerox, could I come and visit you and make my fonts by measuring it, by sort of replicating what I thought I seen Butler doing. And they said, sure, but then we own your fonts. In other words, every time, I was just going to get some mathematical numbers out of it. I was going to say, you go 102.3 here and so on. And I thought, that's mathematics. You can't, but they said, no, you have to keep that. So since they told me I couldn't do that, I had to design Metafont.
And the other thing is that there were a whole bunch of competing technologies in the font world. Bitstream liked, and Apple were developing their fonts with segments of circles. So they were second order curves. Ivan Sutherland taught me about Bezier curves. And Bezier curves have the property that they are wonderful inside of a computer to generate. They're very recursive. They're just wonderful. They're very, very fast. So it was an obvious choice to build the entire font library out of Bezier curves.
Liz, you're next.
I wanted to add another point too. Because of a programming language, there were no applications when we first launched the Apple Laser Writer. And we wanted to show the Laser Writer with PostScript to the publishing world. And so we were asked, or we collaborated with International Typeface Corporation to do an announcement in New York the day after the Laser Writer was introduced. But of course, those people expected type specimen sheets, the old-fashioned ones where you showed every size as available. If PostScript hadn't been a programming language, I could never have generated those type specimen sheets. And I wore out the Laser Writer at Adobe trying to produce those, because we had to show them exactly what we were talking about, that what you see is what you get on this piece of paper that was produced on a low resolution as well as a high resolution typesetter.
Liz and John, traditionally type design, when you scale a font to different sizes, it's not a linear scale. You want bigger X height and a sturdier letter at smaller sizes, and you want something more delicate at larger sizes. Could you address that?
Yes. We then had an idea how you could have one font, essentially one sort of master set of curves, and parameterize it in such a way that you could get multiple masters. In other words, you could, from the sort of canonical design, you could automate the production of all the condensed versions. And even though not necessarily italic versions, because those are generally different designs, but Adobe put out a whole bunch of multiple master fonts that were parameterized Beziers.
We had
Hanson, next.
Hi, I have two questions. My first, earlier you mentioned that in order to compete against TrueType, right, Apple and Microsoft's collaboration, you innovated your way out of the problem and brought the technology to scale outline fonts down to screen size. Was that Adobe Type Manager?
Yes.
Okay, all right. And My second question is, what was necessary to turn PostScript into display PostScript for the next?
It was just the imaging model. It was essentially just the same code.
Not being picked.
Essentially, it was the same code that we licensed to Steve.
What was the time frame for that?
That was, he left Apple in 1985 and founded Next, and Steve and Adobe have always had a really good relationship, except when we implemented applications for other machines.
This is late 80s, we're still talking about then still?
Yeah, this is 85.
What else? Give a couple more minutes on this, and then I want to switch to our next subject. Go ahead.
I'd like just to fill in a few historical details. One is the debt we owe to French mathematicians. I think Don will know this, but in Hamburg, Peter Caro, many of whose font library was later used by Adobe, had developed something rather like the Adobe's method, but in the 70s. He used software to distort outlines to grids, but it was done offline in order for font manufacturers like Linotype and others to then create their bitmaps. And Peter Caro never had the idea of putting this in a machine that would do it on the fly. So he called the program PASA, because he took one pass to figure out the parameters of distortion and then a second pass to make the bitmaps. And he used Hermite form of splines, cubic splines rather than Bezier splines. So there was a convergence here, but what he never thought of was to actually put them in the printer, in the raster image processor. And in 1984, Mike Sheridan, who was a type manager at Imogen, met with Peter Caro. I was there, and he said, have you ever thought of putting this in the machine so that Imogen could have scalable fonts, outline fonts? And a fact of Peter Caro is that he would often say no before he'd thought it through. And so he said, no, I want to tell you about font servers, and that we could have these servers that would be serving fonts. And so that the possibility that he would have taken that next step was then dashed. 5 years later, he did make a program to do that, and it was in the running of programs that Microsoft was looking at to make before they adopted TrueType. So, but it was a different mathematician and a different implementation, but he also liked the cubic splines and the concept of distortions. The other is that Caro also developed a predecessor to multiple master technology, and he said that for years he tried to distort a single font to do this properly. Never did until his partnership in their business. He was a high-energy physicist. He said, well, why don't you just interpolate? And then from there, Caro did a number of demonstrations for font manufacturers. And the first typeface to actually use this interpolatory method was the Matthew Carter's Galliard, which came out in 1978. And he flew to Germany and spent many a sleepless night and with jet lag as they coded in the interpolations. They digitized in Hermite splines a lightweight and a bold weight, interpolated the weight in between, which would be called bold, and extrapolated black. And then Carter looked at the black and said, well, I'm starting over now, and I'm going to redraw the black because the extrapolation was not sufficiently quality to make a real typeface that aficionados would like. So there was this parallel development, but it never took the crucial step to make it in the printer and to embed it in a programming page description language.
Tom, you had a question?
Yeah, so you haven't said anything about how PostScript handled the bitmap page elements that were sent to it. Was there anything challenging or innovative in that, or was it relatively straightforward? Well, pages have got bitmaps in, right, as well as vector graphics and text. Was there anything interesting or challenging in how PostScript dealt with those?
One of the biggest challenges with doing photography on a printed page is to do the halftoning. And we, in fact, struggled quite a while with that, working on it. I think I mentioned earlier today that my father was a letterpress photo engraver. I recall bringing home a sample of some of our first halftone work and showing it to him. He took out his loop, because photo engravers always have a loop. And he looked, and he said, "Charles, that doesn't look very good." When my dad called me Charles, that was bad news. So I said, "Well, I understand, Dad, but we're going to get him." He said, "Okay." And about 6 months later, I knew the rosettes were perfect. In fact, better than anything I'd ever seen come off of his proofing press when he was still working. So I took it to my dad. I said, "Here, Dad, here's another sample." He took his loop out. He looked. Big smile, and he said, "Charlie, you finally did it." And to me, that was the high point of my printing career, was the fact that I
I
could
think
show
we
something
probably
like
have,
that to my dad.
we probably have 30 half-toning patents
Yes.
on digital half-toning. I don't know the exact number, but it's up in there.
There's a lot there.
One other general question. Are these the three major products during the 1980s that you've discussed? Are there any other significant new
yes.
things you developed?
Oh,
besides-
yeah.
Illustrator.
Illustrator was a breakthrough product. So we said, gee, there was a really nice program at Park that was called Draw that Patrick Baudelaire did, and he used splines. And I was of the opinion that the spline technology didn't give you the kind of control that you needed to do very precise illustrations. It's sort of, you got the curve and it sort of, you mushed it around until it looked okay. With the Béziers, so I suggested to Mike Schuster, who was one of our programmers, why don't we just take the PostScript imaging model and turn it into an illustration program where you control the Béziers? And you have handles on Béziers and you crank them up and down. And it took a learning, there's a learning cycle to Illustrator, but once people master Illustrator, they sort of love it. And that's where that came from.
PostScript for non-programmers.
Yes.
Right, in fact,
Don,
John's,
I'm sorry. Go ahead,
let me
finish
just
up.
finish part of this story. John's wife is a graphic designer, and once she got the laser writer, she wanted to use it, but she wasn't a programmer. So John was having to program in PostScript to do her illustrations for her, and that motivated doing Illustrator.
Don, go ahead.
I can't resist mentioning that my Metafont program has its own way of rasterizing, and so still my books today are printed with bitmap fonts, where I've actually, my algorithm control every bit in them, and then I send it to PostScript, and it gets printed with exactly that bitmap as a Type 3 font. But unfortunately, Adobe has never blessed Type 3 fonts. They put them in sort of kicking and screaming, so that when I convert to a PDF file, I can't search. I can't find any of the words that I did with the letters that I digitized myself, and therefore when I do the printed version of my book, I rasterize with the way that I built in. But when we have the PDF version, I have to go to fonts that were designed by somebody outside of my control.
You're going to be, one more thing I want to finish here, and then we're going to do the rest of the time on PageMaker. We've talked about the laser printers. We've talked about the laser writer. Now, I'm not really going to talk about the business story. Is there a technological story that we should be discussing? You started on that a little bit ago about the technology that Starkweather, is that the gentleman's name, brought to that? Were there other major changes that made the use of the laser writer effective here?
Well, the biggest change was that you could afford enough memory, you had a low enough resolution, you could afford enough memory that you could compose, you could have a whole frame buffer, which meant that you didn't have to worry about timing issues when you were rendering the page.
What was different about laser writer versus the other stuff that was
The
around?
memory was cheaper.
Memory was cheaper.
That was the main thing.
Why?
Well,
Why? Because time goes on. Moore's law says things will get cheaper.
well, the other thing is, though, we had to do, the biggest and Jonathan can verify this, is we also, when we announced the laser writer, announced the Linotype 100. And the fact that we could output to 1,000 or 1,200 spot per inch machine was mind-boggling to people. I mean, but you can't have a frame buffer for a 1,200 spot per inch machine. You couldn't buy enough memory to do that. And so what you had to do is build a display list that you could sort, and you could buffer into band buffers and then rasterize out to the Linotype machine. So there was a fair amount of technology.
Was the Linotype machine asynchronous?
Yes.
Because this technology was developed at Park to run synchronous printers, where it's much more difficult. Because each band, you only have a fixed amount of time to process each band.
See, and here they had a direct drive motor that was driving the film. Okay, and so you could stop and start.
So a couple of points here. First of all, there's another key thing about the laser writer. The problem with xerography was that, and anybody who had copiers in the 60s and 70s knows this, that with your copier came your serviceman. Because they break, they have to be fixed, and you had to have service for it. What Canon did was it took the problem and turned it into, it packaged the things that were going to break into a consumable they could sell, into razor blades. So that made possible to making a really low-cost copier that could be sold in mass numbers without having to have a huge field service organization. And that was the basis on which the stuff got built.
I'm still confused. Who owned the technology on the laser writer? Was that Apple?
The printing device was owned by Canon Technology.
Isn't that a later point in time?
No.
No.
Apple bought them from Canon.
And put their own electronics.
Put their own electronics into it, which included PostScript. We had the intellectual property rights to PostScript and licensed it to Apple.
So in other words, it's Canon who does the first technology work that was built into? I thought you were saying that work on the laser printer was done
You don't
here.
understand that software is technology.
I've been told by these guys
But-
it isn't.
but Bert-
Hardware is technology.
Bert,
That's
Bert,
nonsense.
Bert, so,
You're not on the mic.
it's a copier. If you take the copier out of it and drive it with the
So that's the
electronics, then
difference.
it becomes a printer.
So that's, I have these multi-purpose machines, multi-function machines. I don't know the difference.
So the second thing I wanted to say was that one of the really crucial things here was to deal with Linotype. Because Linotype owned the standard font library. There was no question about the quality of Linotype fonts. Anybody less than that, there would have been a question about, is this really commercial quality? To have Linotype and to have a high-resolution Linotype output typesetter as part of the package when this was introduced was absolutely crucial, because that said, this, even if most of you people never go beyond laser printers, there is always the possibility here to go to a service bureau and get commercial quality, high-quality output from it with the same type fonts that are used by the experts.
And we worked a great deal. Finally, Steve always gets the credit for appreciating typography because he took a calligraphy course in college. You know, and I'm sorry, I think we were a forcing function.
Fair enough.
Typefaces, because we wanted to make sure that they had a range of faces that would work for a lot of publishing applications and not just a selection of display typefaces. So for example, besides Helvetica and Times Roman, which were probably the most popular, and Chuck can add on to this, on both the sans serif and serif, we added Palatino. We put in ITC American typewriter, and everybody afterwards sort of wondered why. Well, that was because majority of the people in the first were used to typewriter look, but it wasn't a proportional. We didn't want to put Courier.
It wasn't fixed pitch.
No, it wasn't fixed bit, wasn't Courier, wasn't Roman BS, but ITC American typewriter typeface looked like a typewriter
Oh, Courier
face,
was there as
but
well.
it was beautiful. It was, and so,
To get just one example of how few people and how small this world was at this time, the reason Palatino got in there was because you and I like Palatino.
Yeah.
Okay? Okay. It was that simple.
and also, I liked Herman's off.
Hard. Which was actually not a very good decision, but I still like, well, I don't like Helvetica that much, but I do like Times Roman.
I disagree. You had the right choice. Absolutely. You picked the right choice. Absolutely.
Oh, wow.
Absolutely, because Times Roman is a universal font. Helvetica is a universal font.
Running 2 more minutes. Don, you had a comment?
Yeah, I asked, wondered if Jonathan and Chuck would comment. I mean, it was my impression that Monotype was also one of the world's greatest libraries of fonts in those days. I visited Red Hill at the time, and
At a time, please.
and then I wanted to mention that Herman Zoff at one point insisted that Optima would never be made digital, and he had a special thing built into the PostScript font, which I had to actually break into and disable, that it could never be used at less than 100 dots per inch resolution. 1,000, I'm sorry, 1,000.
2 comments on that. Yes,
Just
the Monotype library, Monotype actually, when back in the metal days, Monotype was the standard for the highest quality output. What had been during the photo typesetting era was Monotype lagged. Monophoto was a really strange machine. Monotype did not make photo typesetting machines that were competitive in the commercial marketplace. So by the time PostScript came along, for most people who were active practitioners in the field, Linotype had become the standard for comparison. Yes, there were particular fonts that always gave problems. You mentioned one. Souvenir was another one. There's these little delicate curves to it that were absolutely just a bitch to do it at low resolutions. You just couldn't do it right. Would that make it look clunky?
We did put Optima in.
Yes.
Thank you, Bert. I've just had a question that's been on my mind for a long time. So I remember the guys, people who worked on the 9700, it was all about 2 pages per minute, super high speed, trying to keep up with the printer, multiple pages in flight. So you had to have the image ready because you were launching the paper from the paper tray before you had the image. It was a whole bunch of synchronous problems. And the commentary on the laser writer was always, oh, they can stop between pages. So if they have a really tough problem, they just wait, they get the page done, and then they do the next page and they restart the printer. So what happened, I don't know enough about this, so fine, the laser writer works and that's great. And what happens when you try to step up the performance on a PostScript design to a really high-speed synchronous printer with 7 pieces of paper in flight?
More buffering.
Is that, maybe that's just, oh, yeah, okay.
Memory's cheap.
Memory's cheap, yeah. Hit it with a big hammer. Yeah, okay.
An answer that wouldn't have worked in the 1980s.
Yeah.
And certainly not in the 70s.
Yeah, not the 70s.
Oh, yes. No chance in the 70s.
I didn't hear the answer to, and I don't know how. At one point, Gary Starkweather and Xerox are in control of the IP for laser printers, I think I heard. And then jump forward, and Canon is the company that has the IP, is the way I interpret it.
I thought we agreed nobody here was an expert on this topic.
Oh, is that how it concluded? Okay.
The only thing I know about that was that Canon did patent the single cartridge, which is why its competitors ended up having to break it in 2 pieces, have 2 separate cartridges.
Well, they missed a bet there. They could easily enough have made a 2-cartridge version, right, and patented that too.
That's right.
We'll break this up. Last question, and we move on.
Who chose Century Schoolbook for the Laser Writer 22 set?
It wasn't me.
Okay. It's important because it links in a completely accidental way the fact that Ginn and Company sponsored the development of Century Schoolbook in 1919.
Enough, stop. We're done with PostScript. Next subject. Oh, Paul Brainerd, let's talk about PageMaker. you're not on the screen anymore, forget it.
Okay. So basically, PageMaker came about because we were all without jobs. And I related this before. So Eastman Kodak bought ATEX, trying to diversify its business model into non-photographic products. And Charlie Ying and I went up to Rochester, went up to whatever floor it was, up on the top. And Charlie would be an advisor to try to get them, because they were making some really good technologies. But anyway, I was running the West Coast plant doing all the microcomputer development, including the graphics display terminal that was going to be used for display advertising. And they'd made a decision after acquiring ATEX to close down that research facility, which was a little crazy given the fact that we were the future of the income stream. But nonetheless, I one day walked in and they told me that this was going to happen. I laid off 120 people, walked out the door, and never looked back. But it gave me the stock that allowed me to start Aldus. And what was going on in that time frame, which I didn't know, so I had my pick of the engineers. We had 17 engineers working on graphics and typography and composition, and we had all the specifications written for the newspaper industry that I'd had in my mind for years. But now we had to start all over. And our thoughts were that we build on top of the microcomputer revolution in terms of the new personal computers coming to market. The problem, of course, was there wasn't a graphics-oriented machine at that time. There was only the IBM PC, and we were not too excited about the graphics card that came standard in that, because there was no bitmap graphics in it. Jonathan and his father, John, I'd known since Volume 1, Issue 1. I've been a subscriber, and I talked to John after starting our company in 1984, and he said, I can't say who to talk to, but you need to go to Silicon Valley and set up 2 meetings. One is with John Warnock, and the other is at Apple Computer with a guy named Bruce Blumberg. And so I took his advice, signed the non-disclosure agreements, went down to Silicon Valley here and met with John in your office. I can still remember sitting in your office, and I looked up, and you had a page of the Gutenberg Bible there. And I said to myself, this guy knows type. He has respect for type. He has respect for the history of type, because I had the same thing in my background in design and newspaper production and typography. So I was impressed that you had a page from the Gutenberg Bible. And then I went over to Apple and, of course, learned about the Macintosh. So desktop publishing, I've always said, is based on a 3-legged stool that I referred to earlier. There's PostScript and the technology we've just been talking about, fundamental breakthrough in resolution-independent output, licensed to a large number. Everything up till then was proprietary systems with their own connections to a particular thing. So that was an open standard. Apple had the Macintosh, and then we had the application, because from my background, in terms of having worked in the industry and knowing what people wanted to do, and we were focused on small, short documents. Up to the first version only supported 16 pages, but integrating text and graphics on a page and putting it out to a printer. And we needed the LaserWriter in order to do that. So those were the 3 legs of the stool that all came together because of Jonathan telling us to get together, basically. And I had 4 engineers that I picked from the Aldus group. We worked, and the other thing that happened is we went over to Apple Computer in Bellevue, Washington, and there was a salesperson there that worked in corporate sales. And lo and behold, we explained what our idea was. Most people we talked to about desktop publishing or the idea of publishing on the Macintosh or on a desktop computer really didn't understand what we were up to. But this guy did, and lo and behold, one afternoon, this guy shows up and pulls out 2 prototype Macintoshes out of the back of the trunk, brings them in and said, I think you guys should play with these things. They just showed up. This was not top down from Apple. It wasn't working with John or anything else. It was bottom up from a salesperson in a regional sales office who just thought that we had a good idea. And he brought us those 2 Macs, and we were so excited. We finally had a development environment with a bitmap graphics display and a graphics language that we could work with, so we didn't have to build everything from scratch, because the GEM operating system didn't exist and Windows didn't exist. And that would have taken us an extra year to get to the application level in order to be able to get the page layouts working. And our goal was also the introduction of LaserWriter in 1985. So we had 1 year to get there. We'll go into the business stuff tomorrow. Mostly all the story, though, is about market, sales, and how we went about rolling this out and building a marketing plan for Apple at a time when they really needed it. We'll deal with that tomorrow. So what did we have to work with from a technology point of view? We had these 2 Macs, Pascal development environment in the early days, running on a Lisa. We only had 64 K of memory, which was really not an adequate. Until the 128 Mac came out, that was really when things got going. Originally it was written in Pascal. That changed in, I believe, System 7 to C and then to C++. So we were always having to rewrite because the development environment was changing around us. Quick Draw versus PostScript. There were all these standard issues that we interjected ourselves in from time to time. But our story was more of working with the users based on my background. The vision for PageMaker was basically me working with the engineers because I'd done paste up, the exacto blade and so forth, and I work on all the controls. The floating toolbox was the first floating toolbox, which was really difficult to implement. The whole idea of the controls at the end of the page and having those go up and down, window shades we call them, to indicate where you wanted to end the line of type. All those interactive controls we could build on top of QuickDraw. So it took us a year. We demonstrated it at the LaserWriter announcement, and people were just amazed with the output quality coming off. I hired a graphics designer from downtown Seattle. His name is John Anderson. He'd been in the business for 20-some years. And we're working with Mac Paint, Mac Draw, and Word to try to put together pages that looked half decent graphically. Managed to get 3 pages done. And those became the hit at that initial announcement in terms of people in the graphic arts industry. And then we worked with a really top-notch designer to really do the marketing materials that we'll talk about tomorrow. And I was also at that ITC announcement in New York. And the story, you were actually in attendance, remember?
Well, I planned it.
You planned it. But Steve was there.
Yes, Steve was there. What was important for John Warnock and Chuck Geschke, and to have Steve there because of the Apple LaserWriter, and also Wolfgang Kummer, because he was head of Mergenthaler, and also ITC, because they ended up being the sort of the studio where a lot of people expected to have new type, and they were putting out newsletters and et cetera, and Aaron Burns had the contacts with the publishing industry. And we felt at Apple that if we didn't introduce, or at least we did at Adobe, if we didn't introduce the LaserWriter with its capabilities and its connection with Linotype's output capability to the publishing industry, and they found out about it later, just sort of haphazardly, they would never understand what we were accomplishing. And so that's why we went to ITC to do it.
So we went to ITC in New York on whatever avenue and had this fancy place. And, you know, I understood the industry, and we were all just very, because we knew what was going to happen. And so we were trying to navigate and get their endorsement in some kind of way, or at least not their outright resistance. And then Steve, so we're all working off the script, right, in terms of messaging. Steve walks in the door and basically says, "We're going to put you out of business." Remember that? He didn't stay on script. He didn't do anything. He just said, "This technology is going to put you all out of business." And I looked around the room, and these people, all these highly esteemed people in printing and publishing that day were, "Who's this kid from Silicon Valley that's telling us about our business?" And I think he just he let them have it. And I couldn't believe it. I just couldn't believe it. We had many fun stories with Steve, but that was definitely not what we had planned that day.
I don't remember it quite that way.
What do you remember?
I do remember that Steve sat in the corner a lot and was very quiet. So,
What was the result of the meeting? Let's keep going.
well, I think the result of the meeting is we introduced exactly what we wanted to do. We showed them the technology was there, that we were going to make breakthroughs in publishing opportunities. I think the industry that was most impacted was the middleman, the composition people. I was on the National Composition Board for a while, National Composition Association Board, and they realized that they were going to go out of business if they didn't, quote, move on with this technology, and they did. Some of them did, and some of them went out of business. But I think that it was a successful meeting.
So here's a precursor to that, that this was the stories. So when the Mac was first introduced, the year previous to that, we'd arranged to have a demo for it. The CBOL seminars in March, we had a little demo area at that point. Arranged to have a demo area for it. And so we had two ladies from Apple going around the country from the announcement in January. They'd spent the subsequent weeks going around the country trying to promote the Macintosh. I'll never forget, they walked in Santa Monica, they walked in just totally bedraggled. They were beaten down. They were getting no response from anybody. And suddenly they walked into a group of people, and this was before the laser writer, before PageMaker, a group of people who got it, and the reason was that everybody in publishing, the professional type people, had gotten this vision already in the early 80s of the future of being a WYSIWYG workstation. Okay, I mean, the people understood that's where things were going to go. And here was a baby WYSIWYG workstation, and they could see the potential for that. And so right at that point, it should have been clear to Apple that that was their market.
One of the questions I had when I was doing my history of word processing was when publishers began accepting electronic submissions from authors. And it turned out that it wasn't until much later than you might have thought. For many mainstream publishers, it wasn't until the mid-1990s. And so the reason for this turns out to be that you had an enormous technological base installed at the publishers, and they weren't willing to convert to new technologies on any kind of rapid timetable. So I'm just looking at my old research notes. Simon & Schuster had $6 million worth of Selectric typewriters. Penguin Putnam didn't get their first computers until 1995. So I'm wondering about the sort of disconnect between.
Here's a note.
Just a second, John.
Okay.
The point, of course, is that one of the things that tomorrow we talk about with Aldous is the market turned out to be different from the market they had expected for things like what you're just describing there. I believe that's the case.
It is the case, and we'll cover that tomorrow.
Here's a note for you, though. As far as I know, the first author to give a novel manuscript in electronic form to a publisher was John Saul, who writes sort of horror mystery story type things. In 1977, he's written it on a linear word processor. And after that, John went around to, they have all these convention people talk, and all the other authors wanted to have him talk about word processing. So the authors got interested in this stuff fairly early on.
Yeah, which exactly right, and that timetable, right, so that story is in the book as well as other authors from right about that same time, but it took much longer for the publishers to get there.
Right.
I'm going to ask a stupid question. What did PageMaker add that made why he saw that the two things between PostScript and PageMaker suddenly made this a viable business proposition?
On a low-cost workstation you could buy we ordered the magnitude cost. Up till then, you went to a print shop, the investment required was about $100,000 for a typesetting system with terminals and so forth. We brought that down with a laser writer with a Macintosh, with one or two Macintoshes, to $10,000. So that was an order of magnitude reduction, and then made it, most importantly, easy enough to use without type up or markup. In other words, as much WYSIWYG as we could get into it at the time, so that people didn't have to have specialized training.
The quality anywhere
Quality
near
was
as good?
fantastic as long as you printed because of the PostScript.
And
And the promise of Linotype, when the Linotype 100 came out, I mean, we could meet anybody's quality standard at that point.
And the commercial systems that were being sold for $100,000 were not only expensive, they weren't suitable for the smaller cuts of jobs that PageMaker was sold for.
So our customers we'll talk about tomorrow ended up being the office users, the newsletters, the religious organization. I got a phone call one day from one of our religious customers in the Midwest, and I said, well, how many of these are you printing on the laser? I mean, they were doing an offset printing, but he said, we're printing 600,000 of these a week. And I said, oh my God, I didn't think that was possible. Suddenly, I realized that we were really going to have a fundamental revolution here.
It was a religious experience, is that it? Tom?
All right, so there's a version of the history of Apple that says that Steve Jobs went on a vendetta against the Lisa and insisted on replacing it with the Macintosh being a deliberately crippled machine with only 128K of RAM, no hard drive support, no slots, etc. And one of the questions that only after he was fired and they released the Mac Plus and put back a hard drive and particularly the Mac 2 and slots, that PageMaker could save the company, etc. Now, what that's made me wonder is, if that had never happened and there'd just been, say, an improved Lisa with a faster processor, is there anything about Lisa that would have been a worse platform than the Mac to have developed PageMaker on?
Cost 4 times as much.
We never considered the Lisa as a viable option for our market.
But it was already, the decision was already made inside of Apple that the Lisa was going away.
Yeah.
And by the time any of this came about, the Lisa was already
It was
gone.
dead.
And the Mac was either about to be launched or had been launched.
Yeah.
So it's kind of a moot point.
But if the previous cost point was $100,000, and I know Lisa price came down, Lisa is $5,000, and when you consider the cost of the laser writer and the system as a whole.
Well, there was actually a
Absolutely could
developed version. CompuGraphic developed a software called the Personal Composition System.
Yes, Personal Composition System.
Yeah.
Right.
And they announced it. They made a lot of promises at the announcement about future versions and what would be in them. But and they bought in volume millions of dollars of leases from Apple that they could resell. And so they would resell us with some kind of printer and some other boxes and software. And the starting price was $40,000.
And it ended up producing lousy type output.
Do you have a comment on this?
Can you clarify what you get for 10,000? Would this versus 100,000? I'm thinking about the quality. I mean, if I'm just going to have a Canon laser printer, instead of a Linotronic, I don't see how I can consider that to be really publishing. So.
There was a pathway. So
Okay.
for most of our customers, 300 dots per inch was fine for a newsletter or internal publication.
Okay.
Not for all of our customers. Some of them needed a higher quality output, but we had the Linotronic 100 with PostScript, and we could provide that whole continuum of quality of output.
How much did the Linotronic cost?
But the customer didn't buy the Linotronic, the Service Bureau bought that.
Okay, the server would do that?
You sent your PostScript file to the Service Bureau to get it printed in high quality, after you'd iterated 12 times to get it to be the way you wanted on the laser writer.
But you're going to get exactly the same output that you got on the laser writer, so you don't have that proofing process and losing control of the process. Again, it's about saving time, saving money, and having control, the emotional control.
But remember, the Linotype's producing film that you then take to a printer. So what you've done is you've created a master camera-ready art, and you could look at your proofing capability of the laser writer, and it was like camera-ready art. So you knew that when you went and sent to the typesetter that you were going to get exactly what it was, and you could send it to the printer, and it was black and white, and you didn't really have much proofing problems at all.
Okay, well, at Stanford, we got an alpha type, which cost us $25,000. And we got apps, whatever it was called, and I don't remember the cost of that, but those were giving us actually. I might as well mention that our alpha type was used by Andy Bechtelsheim to print the circuit boards on the first Sun workstation. He designed his own font to do the typesetting of the circuit board.
Yep. But the APS-5 was a $100,000 machine. That was a breakthrough because previously machines of that sort had cost over $300,000. Okay, but we're talking different order of magnitude.
So this may be more appropriate tomorrow, but it sort of fits into this conversation. You shouldn't assume that the Apple sales staff was all that happy with the laser writer because they couldn't imagine selling a printer that costs 2 to 3 times what the computer costs. And they were going to rebel. They had a meeting in Hawaii in October, and they said, you know, we can't do this. And Steve said, I don't care what you think, you're going to do it. And so he put his foot down, and they went to market.
The economics were really interesting. The parts cost on the Apple Laser Writer was $7,000.
Sorry, how much, John?
$7,000. It had no margin. Steve was selling it at cost. And he had enough, and what he told everybody in the management meetings that we went to is that the price of memory is going to come down. And he said that will give us margins. And so when it was announced, it was a $7,000 machine that cost $7,000 to build. And about 2 months later, the price of memory dropped. And that was the major cost component in the device. And, you know, the guy really, he deserves his bad reputations, but he also deserves the fact that he had an enormous amount of vision.
Point. Paul, what do you want to add? We're going to be breaking up in about 2 minutes. You want to add anything further to the story on PageMaker?
Again, I think it's more of a marketing and sales, and we'll get that tomorrow because some really critical things happened after, right at this break point.
One technological question. Did you have any competition?
Oh, yeah, all kinds. They're coming out of the woodwork.
Wrong question. From the technology standpoint, was there a different set of alternatives that could do what you were doing?
In the software sense, yes. Microsoft, in fact, had a Macintosh typesetting program. It was developed by a third party, and Microsoft brought it in-house. And guess who was the product manager? Melinda Gates. Melinda wasn't married to Bill at that point, but Melinda was the product manager. But it never went anywhere inside of Microsoft. But we were scared to death that Microsoft or one of these other major publishers was going to...
When did Quark come out?
Quark didn't come in for another year or two.
Okay.
Yeah.
We had Lee and then Bob.
Lee.
Then we're finished. Yes, Lee?
I was just going to ask you about, you mentioned some of the core developers that you brought from, I guess, that had just lost their jobs. You got to pick them up. Who was the core engineers? I know Jeremy Jake, and then I guess Ted Johnson came later during the Windows version, but who were the first core engineers?
There was Jeremy Jake, who went on to form Visio and then joined Microsoft and developed other companies. Mike Templeman, he was probably one of our key. Dave Walter, the user interface, and Mark Sundstrom. Those were the 4 engineers. And we would have failed as a company. We all got in my car and went down Interstate 5 because we thought we were going to sell to newspapers because that's what we already had the specification for. And we realized on that trip that the newspapers did buy by committee, and their timelines for getting a decision made were typically 18 to 24 months. And we didn't have money. If we'd waited that long, we'd have been long out of business. So we really that changed my mindset entirely, that we needed to focus on this smaller publishing market and make it as easy to use as possible and really abandon that the typesetting market, the traditional typesetting.
Bob?
So I just want to, I don't know if closing comments are appropriate, but I just want to echo something John just said. So we've talked today a lot about technology, but I think there's a very important thing that we haven't said much about, and that is the huge changes in the economics over the period we've been talking about. Now, there'll probably be more opportunities to talk about this tomorrow, but I would urge everybody to mention what things cost. And if you need to normalize it by an annual salary of the user or something. Because the real big change, yes, the technology was there. That was fun and nice. But all of this stuff I think we're talking about today, you could argue about it was done at the precipice of affordability. And the affordability is not just what it costs, but it's what the market you were trying to sell into could afford. The Alto was at the precipice of affordability in some sense. And all of these were explorations at that edge. And perhaps as things mature, toward the end of tomorrow, perhaps, as we all get tired, we'll no longer be at the precipice of affordability. But you cannot talk about this without understanding the incredible, the exponential change, this changes in the exponent of the prices. It makes a huge difference.
Of hardware?
Everything,
Hardware.
but hardware.
Software doesn't get cheaper.
Yeah, I was saying, the software didn't get a hell of a lot cheaper. Pardon
Well,
me?
it did, actually.
But fonts, the whole price model, the whole business model for fonts changed.
Software did get a lot cheaper. I mean, look at Microsoft Office. The components of it are sold for $1,500 in the mid-'80s.
This is a subject I'd never even thought about, okay?
But the hardware price and the software price are related, because hardware prices go down, the market gets much larger, and therefore you're selling software in much larger volumes. So the whole pricing model changes. So the pricing now, so to some extent, the hardware prices drive software prices.
Software people. Gentlemen, it is now 5 o'clock. We are exactly on schedule. And we've actually caught up completely thanks to your speed this afternoon.